So for this topic, rationalizing the denominators, we did a little bit of that in the previous lessons, but maybe you forgot. Now, rationalize means to make rational, okay? Make rational. And what that means is that the denominator needs to be able to be written as a rational number. Now, rational numbers are written in the form A on B, where A and B are integers. Right. So, for example, you could have 3 on 4, 6 on 1, which is 6, for example. So we want to make the denominator a rational number. Okay, so if you have something like, the simple one would be like 1 on root 2. Now, root 2 is not rational because we can't write that as a fraction of 2 integers. So root 2 is root 2 on 1. Well, 1 is rational, okay, but root 2 is not, because you can't write root 2 as a fraction of integers. So both of those have to be integers as well. So A is an integer and B is an integer. So 6 is rational because 6 is 12 on 2, right? 12 on 2 is 6, and 12 and 2 are both integers. They're whole numbers. Okay, they can be negative as well. Anyway, so we want to get rid of this root 2. So if you type that in your calculator, it will change it for you automatically, but I would want you to show me how you get this as being a rational number. So what you do, you multiply this number by itself, top and bottom, root 2 on root 2. Okay, now we have a fraction multiplied by a fraction. So you got 1 times root 2 on root 2 times root 2. 1 times root 2 is root 2. And root 2 times root 2 is root 4, which is 2. Okay, so now that has changed. Your calculator will do that for you anyway, like that to that. Okay, so now your denominator is a rational number. It's a whole number. It can be negative and it can be a fraction as well. That's no problem. So that's a simple one. So let's look at the examples here before we go too far. So you've got root 7 on root 3. Now root 7's a numerator, so that's okay. You can have a surd up there, but we want to make this root 3 a whole number, a rational number. So just multiply by that number, top and bottom, here and here. Okay, and root 7 times root 3 will be root 21. And root 3 times root 3 is root 9, which is 3. So now your denominator is 3. Good. So it's a rational number. Now, when you get to these problems where you've got 2 parts, you see you've got 2 parts here, root 5 and 2. Now, we can still do it. You still will get down to 1 here, which is good. It's a rational number. You need to multiply by the conjugate, which is written up here, this word here, the conjugate surd. So what that means is you basically take your number, root 5 minus root 2, and you write top and bottom here, but you change the sign like that. Don't forget to change the sign here. If you don't, you'll end up with irrational numbers still in the denominator. So take this number, change the sign, and then multiply. So we ended up with 5 times root 5 plus root 2. That's in the numerator. And then this here, you can recognize this rule here, A minus B, A plus B. You remember that rule? And that's what you want, which will give you a squared minus b squared. And by doing that, your surd is going to disappear. So a minus b, a plus b is a squared minus b squared. And root 5 squared is 5. 2 squared is 4. Gives you 1 in the numerator, the denominator, sorry. So 5 on 1 is 5. So your denominator here will be 1, and you don't need to write that if it's 1. Okay, so the same idea on this problem. You've got surds everywhere. So you basically look at your denominator, you will write this number again, but you will change the sign here, like that. If you can do any simplifying first, you can do that first, but this is what we got. So then we need to expand the top here, which is that bit, which is multiplied out. And then your denominator becomes a squared minus b squared. So I'm just using that rule again. So a minus b, a plus b, and then I apply that down here to give a squared minus b squared. Remember that from grade 8 and grade 9. So the good thing about this rule is that we'll cancel your surd because root 6 squared is 6 and 2 squared is 4. You'll get 24 here. And root 2 times root 2 is 2. So you'll get 22 in the denominator. But remember to expand the top, which is what I've done there. I've just multiplied that out fully. So the way to do that, we had this times this. So think about that. You got 3 root 3 times 2 root 6. So multiply the numbers. Let's just rearrange it. 3 times 2 times root 3 times root 6. So you've got 6 root 3 root 6 is root 18. And then root 18, 6 root 18 can be simplified again. So how do we do that? So 6 root 18 is root 9 times root 2. 2 9s are 18. And root 9 is 3. So 6 times 3 root 2, 18 root 2, which is here. So you should try to simplify all the way. Root 10 can't be, and root 30 can't be simplified anymore as well. So you basically just expand this out just by multiplying out. You'll get this, and then see if any term can be simplified further. And I think you can stop there. There's no common factors or anything like that to worry about. Okay, so you can do some in a minute. Let's have a look at the exercise. I'll give you 5 minutes. You think about these two then. Something here, something here. So I'll give you 5 minutes to do them, okay? Try that. So as I mentioned, you will have 2 minus root 5. So change your denominator to be 2 plus root 5, top and bottom. And expand it out. And this one as well. You can finish it, or I'll do it in a minute. So root 7 plus root 3. Root 7 plus root 3. And expand those. We'll check the answer in a minute. Okay, so for this solution, let's take a look. So let's put these together as 4, 2 plus root 5 on, I'll write it all out. So 2 minus root 5, 2 plus root 5. Okay. So it should look like that because you're just multiplying two fractions. So now we can expand the top line if you like, see what happens there. Actually, I'll leave it. I won't expand that top. Let me leave that for a minute. So you've got 4 2 plus root 5. Let's do the bottom first. So this is the rule a minus b, a plus b, which is the same as a squared minus b squared. So put those numbers down here. So you'll have 2 squared minus root 5 squared, like that. So you're going to get 4, 2 plus root 5. This is going to be 4 minus 5. So you see you've got minus 1 in the denominator. So you're going to have 4, 2 plus root 5 on minus 1. Well, 4 on minus 1 is minus 4. So change that to minus 4, 2 plus root 5. That's finished. You don't want to have minus 1 here, so divide it into the 4. And if you want to, then you can expand that to be minus 8 minus 4 root 5. So for my quiz or homework, either is okay. So you should get that, all right? And this here cancelled with the minus 1. So the minus 1 is gone. Okay, that's that one. So same idea with this one. So we can have root 3 times root 7 plus root 3. Let's just leave it like that for now. On. Now use your rule here, a minus b, a plus b is a squared minus b squared. Okay, so just convert that using your difference of square rule from grade 9. And then we end up with root 3. Let's just leave it like that for now. See what happens. Root 7 minus root 3 plus root 3. And root 7 squared is 7 minus root 3 squared is 3. So that's going to be 4. So if you like, you can expand the root 3. And so root 3 times root 7 is root 21. Root 3 times root 3 is 3. And that's going to be 4. So that's good enough. You can leave it like that. That's your answer there. So now we have 4, which is on the denominator, which is a rational number. So that's what it means by rationalizing the denominator. And that helps a lot when you come to like harder calculations to be able to do this. So you tried C and D. If you've done C and D already, go and try 2 here. We may not go to this one though. This will take a long time and I don't want to show that today. So for this one, you can try that yourself because it's kind of long and you may run out of paper. So we'll try a couple of these and see what they come out like. So do this first. So multiply by your conjugate of that and this one as well. So I give you 5 minutes for that. Well, you've got root 7 plus root 2. One of them may be a rational number. It doesn't matter. We still have irrational numbers here, these roots. So root 7 minus root 2 and root 7 minus root 2. So you're multiplying fractions. So just put it together like a fraction on the top. And so you've got a plus b, a minus b. So that's a squared minus b squared. All right. I'm not writing the whole step out. So in your working, in your worksheet, you can show this step like that. So you got 5 root 7 minus root 2. Root 7 squared is 7. Root 2 squared is 2. Ah, you're going to get 5, aren't you? So 5 root 7 minus root 2 on 5. That's why it's good not to multiply this in. So I don't recommend multiplying in yet because you may find that you can cancel here. which you can. So in the numerator, just leave it with a bracket for the time being. So then you'll get root 7 minus root 2. And the denominator is 1, so that's good. So that's a rationalized denominator. So that's your answer there. But you don't need the 1 on the denominator. So just get rid of that, like that. Okay, so a little bit more complicated because you've got more surds here and there, but shouldn't be a big problem. So multiply by your conjugate. So root 3 minus root 2, root 3 minus root 2, and then put them together if you like. So 6 minus root 3, root 3 minus root 2, and in the denominator, so a plus b, a minus b, a squared minus b squared. Okay, so just convert that using your difference rule. So you're going to get root 3 squared 3, root 2 squared 2. So 3 minus 2 is 1. So the denominator is 1 already. So you're just left with the numerator. That equals 1. So I won't bother to write that again. So 6 minus root 3, root 3 minus root 2. So let's expand it, which would be good. Let's go up a bit. So hopefully you have no problem with this. So 6 times root 3 is 6 root 3. Don't put the 6 in the root sign because it's 6. It's not root 6. So it's 6 root 3. Root 6 times minus root 2 minus 6 root 2. So then you've got minus root 3 times root 3. That would be minus 3. Minus root 3 times minus root 2 would be plus root 6. So you can see here, there's nothing to say. They're all different. All the terms are different, aren't they? You've got root 3, root 2, root 6, and a whole number. So there's nothing else to fact, and there's no common factor. So you can, what I do, I'd probably put the highest root first, but it really doesn't matter. So root 6 plus 6 root 3 minus 6 root 2 minus 3. I just put it in order of the surds, but it really doesn't matter which way you put that. That looks okay. So that's the answer for that one. I think you want to make your denominators the same. So you got root 5, root 6. I'll leave a bit of space. Root 2, root 15. We can both make these root 60, can't we? So let's make these root 60. So root 10, root 10, root 4, root 4. Do you see why I did that? Because now I have a common denominator. So let's put a square bracket around that. I did that because I want a common denominator. Then I can just join the numbers together. So root 5 times root 10, root 50, root 6 times root 10, root 60, minus root 2 times root 4, root 8, which is 2 root 2. Leave it like root 8 for now. Root 4 times root 15, root 60, and square. So now the good thing is, now we have a common denominator, root 60. So root 50 minus root 8 on root 60, and then we square that. Okay, so you've got something on something and square. So if you square the top, you're going to get root 50. So I've got root 50 minus root 8 squared on root 60 squared, which is 60. So you're going to have a denominator 60 here when you square the root 60, okay? So you've got root 50 minus root 8 on 60, and this is squared. So remember, you're trying to do this without a calculator. So root 50 is 25 times 2, so 5 root 2, okay? And root 8 is 2 root 2. Squared on 60. So 5 root 2 minus 2 root 2 would be 3 root 2 squared on 60. You see how long this takes? So then we can square top and bottom. 3 squared is 9. Root 2 squared is 2. 2 on 60. So 18 on 60. You've got 9 on 30. 3 on 10. Finished. So that's your answer to that. So if you don't have a calculator, I mean, that's the way you would do it. Normally, a question like this, you just stick in your calculator, wouldn't you? But for your worksheet, you'll need to show some working like this to show you understand what's going on. So in this section, they want to find the square root of a third. And they're usually written in this form, okay? There's a set way to do these problems, and I'll show you how to do them. And they're very common in Thai books. That's where I actually got it from. So I'll show you how they're done. So let's look at the basic form. So you've got a question which looks like this, okay, where X and Y are some numbers. The first thing you do is assume that we can write it in this form here, okay? So we can write the answer as root A plus or minus root B. So from that, we will square both sides. And when you square both sides, that square will cancel the square root, won't it? So then you'll have X plus 2 root Y here, plus or minus actually. Got plus or minus there. And then on this side, you've got root A plus or minus root B squared. So this is just expanded. So you've got root A squared plus or minus 2 root A root B. That would be plus root B squared. So this is just expanded using your perfect square rule. So A squared plus 2AB plus B squared, like that. We're just using that rule there, which is A plus B all squared. Okay, you don't have to remember how to do this. This is, it's good if you can do this, which we'll practice in the example. So root A squared is A. Root A root B is combined as root AB, and root B squared is B here. So we've got all the parts. So then we compare both sides. So you've got X plus 2 root Y equals this. So you should see that this here is related to this number here because it's the third, okay? And this bit, X here, is a number, is related to A plus B on this side. So I hope that's clear enough. So X equals A plus B, and your Y is equal to AB here. So you actually have simultaneous equations that you need to solve to do these ones here. So let's look at the example, and I'll probably finish this tomorrow. So let's just go through and see if you can follow. Okay, so look at your form. It's looking good because it's in the form root X plus 2 root Y. Write that as root A plus root b. We can use plus because we got plus here. Okay. So from that equation, x is 11. Okay. And then y is 28. So that's written here. And our simultaneous equations are here. So x is a plus b. So a plus b is 11. And y is ab. So ab is 28. And we just solved them. I didn't show how we solved them. So a plus b, I guess I should show you that here somewhere. So a plus b equals 11. AB equals 28. So what I did here, I said B equals 11 minus A. Okay, and then I substitute that here. So these are just simultaneous equations. So then I'll put this number into here. So you'll end up with A, 11 minus A equals 28. So you get 11A minus A squared equals 28. I want to make this is a quadratic, isn't it? So I'll make it A squared minus 11A, put to the other side, plus 28 equals 0. So I got 4 and 7. So A minus 4, factorize now, A minus 7. So A is 4 and 7. So we ended up getting our numbers here. So if A is 4, so I took the number to be 4. So then B must be 7 because 4 plus 7 is 11. So I ended up with my X and Y value here. The A and B values are here, 4 and 7. And root 4 is 2. You can check that in your calculator as well when you've finished the work. So take a look at this one. So we assume, or we let this question, let this equal root X plus root Y. And these are the two numbers you need to find here. So what we do, we square both sides because it's easier to do all the working than try to remember the formula. So can you write that down? So square both sides, and your first squaring will cancel this root here. Okay, so you have 20 plus 2 root 91 equals, now if we expand that, we'll get, let's do the whole thing. So root X squared plus 2 root X root Y plus root Y squared. Okay, so it's easier just to do the whole work instead of trying to remember formulas. I'm not good with formulas, remembering them. So I just do everything. So root X squared is X plus 2 root XY, okay, plus root Y squared is Y. So let's write it all again. And then I will combine the X and Y in the front. Like that. And then I compare these two sides. So take a look at that. So now I can see how these are related. So you've got 2 root XY, 2 root 91. So you can say, therefore, X plus Y equals 91. That's your first equation. You see how I relate them? So this one to this. And then I relate my second equation, 20, to the number here, which is X plus Y. So then you're going to get 20 is x plus y. So x plus, oh, sorry, that's xy. Did you see the error I made? xy is 91. Okay, that's that equation. And then x plus y is 20. That's the second equation. So now we need to solve these simultaneously. So I would take this one as I did in the example, and I could say y is 20 minus x. And then I would substitute that back to this equation here. So that will go in here. So you'll get x, 20 minus x equals 91. So 20x minus x squared equals 91. So let's make it look a bit nicer. So then I'm going to get x squared minus 20x plus 91 equals 0. And when you factorize that, you'll get x minus 7, x minus 13 equals 0. So x could be 7 or 13. Now, in this case, it doesn't matter which you put where, because it's addition. This one will cause you a problem. We'll do this one tomorrow because it's a subtraction. So your two answers are going to be root 7 and root 13, basically. So therefore, you'll get root 7 plus root 13. That will be your answer. And it's absurd. There's no whole numbers in the answer. So you could say, what was the original question? Root 20 plus 2 root 91. So root 20 equals this here. So that's one way you can do it. Not every question can be done like this, but it seems to be a common exam question here and there.